All right, folks, we have a doozy. Students in my sixth period today, we were working one of these problems, and they said, hey, how do you do this? And I looked at it, and we only had like 5 minutes left. I'm like, there is no way I'm going to be able to do that in 5 minutes. So here's the question. A rock is thrown upward with a velocity of 5 meters per second from the top of a tall mountain. The velocity of the rock after 1 minute is how many meters per second? So we did a whole bunch of gobbledygook, multiple formulas, multiple steps, and we've determined at least 2 ways that you can get to the correct answer. There's a shorter way, and then there's a slightly longer way. It's not that much longer, though, is it?
Couple steps.
Couple steps longer. So we're actually going to show both. We'll start with the shorter way, but I want you to see that there are more than one ways to do this problem. So let me erase this. We wrote the steps down. Hopefully it won't take too long. Now, some of the stuff we do in class is pretty simple. This is not one of them, okay? This is an intro to physics class for freshmen. So if they get this math, I am so proud of them because it takes me. Now, admittedly, I am not a math guru. This hurts my brain. But we're going to get there. So if you get this, you're awesome, okay?
You're welcome.
If not, you'll still be able to pass the class without getting this, okay? So the concepts are what we need to worry about for our class. But this question was in our text, and we want to know how to do it. Just 'cause. Okay, daughter number 1. We have our simple method. Step 1. We've got to first figure out how far did it go up. So we're going to be using a displacement formula. Displacement is equal to what? First step. We wrote it all down.
D equals
We wrote it down so I wouldn't have to remember.
VF
VF,
in parentheses squared
squared,
minus
minus
VI
VI,
in parentheses squared over 2A.
Over 2A. Oh yeah, and we're told by the computer.
Erase the one.
Did it not say 1?
Didn't say that.
Okay, so it told us, hey, make sure you're using negative 9.8 meters per second
Even
for the
numbers.
acceleration due to gravity. All right, continue. So we're putting in what we have, right?
Yeah.
What am I putting in? We have 2A is 2 times negative 9.8, which is what?
Negative 19.6. We did most of this in
Yeah.
0.81.
That's fine.
Just use 0.81.
I thought that's what it told us to use. Okay, so what is this? Dividing what?
25.
So our initial velocity is 5, right? Yes, our initial velocity is 5 meters per second, right? And the final velocity is going to get thrown up, and gravity is going to stop it. So the final velocity is going to be 0, okay? So if that's 0, we can just say bye-bye, and we're left with 5 squared. What's 5 squared?
Negative 25.
It's 25. We have 25, and then there was that negative sign out in front. We can't lose that. So we have negative 25 divided by negative 19.6, and we get
1.3.
1.3. And since we know we're looking for our displacement and we're dealing with meters, it's going to be 1.3 meters. Okay, step 1 done. 1.3 meters. What do we do with it? Well, we're looking for the speed after 1 minute. You might think to yourself, well, I only need to know from where it was stopped, but we've got to account for how much time it was going up that 1.3 meters. Right, daughter number 1? Absolutely. So, how much time did that take? What formula did we use?
Velocity equals distance over time.
Our simple, old-fashioned displacement divided by time gives us our velocity. So we are given our displacement, 1.3 meters. We are not given our time, but we are given our velocity, which was 5 meters per second. Okay? And then what we're going to do is we're going to divide 1.3 by 5 to get 0.26 seconds. Then we think to ourselves, well, how many seconds are in a minute? 60 minus 0.26 to get 59.74 seconds.
Not 75.
Huh?
Not 75.
Yeah, that would be if it was 0.25. I made a mistake earlier. Okay, she's not going to let me forget my mistakes. That's fine. So let's hold on to that. Now, what's step 3?
Final velocity equals initial velocity plus...
Velocity final minus velocity initial?
No, equals.
Oh, equals, excuse me. Equals velocity initial
Times acceleration times time.
So it would actually just be that. Was it plus?
Plus.
Plus.
No,
AT.
Yeah.
Acceleration times time. So we have what? We have velocity initial was 0. So we can get rid of that. And then we have acceleration is negative 9.8 meters per second. And our time is 59.74 seconds is going to give us our answer. What is negative? Was it negative? Right? Because it's going down. So negative 9.8 meters per second times 59.74 is?
Negative 586.05.
And then we round to the nearest whole because that's that's what the computer program was looking for our answer. So if we put it in like this, we'll get the correct answer. Does that make sense? Okay, so you've got your answer. This would be in what? Meters per second? Right? Because we're looking for velocity. So the velocity of the rock after 1 minute would be negative 586 meters per second. Okay, that's the first method. Shorter. I'm going to have to write smaller or something because this one gets a little bit wild, doesn't it? Okay, first version done. 1 and 2 are the same, yes?
Yeah, 3, 2.
Oh, dang it, why'd you let me erase it? Do I need to make it smaller anyway?
Yeah. Do you want me to do this part?
All right, second way that you can do it, second method, is longer, but it starts the same way. So again, help me out. And we get 59.74 seconds. Then step 4 is?
We do displacement down, which is...
Yeah, so now we're finding that, so we were up, the rock got thrown up, it got stopped. We need to know how far, this is one way to do it, we can find out how far it was displaced before it stopped, ran out of time, right? What was the displacement down? So displacement equals?
1/2 acceleration times time squared.
Like that. Okay, cool. And so we can plug in, what do we have? We have the time we can plug in, we have that, and we have that. So it's going to be displacement equal to 1/2 times 9.8 meters per second times squared times the 59.74 seconds. 59.74 seconds.
Squared.
Not squared. Oh wait, it is squared. So it'd be like this. Okay, so let's do that first because it's in parentheses. What's 59.74 squared? Hang on.
I didn't have that written down. I did, though. I'm the one who did most of this.
Okay, I provided a little bit of guidance.
3568.
3568.9. And then we're going to multiply that by our 9.8 meters per second squared times our 1/2 to get our distance. Okay, so now we're just going to plug all the numbers in. So you have the 3568.9 times 9.8 times 1/2.
Which is basically 2.
Okay.
17 505.5.
So our displacement is 17,505.5 meters. So this rock, we threw it up at a velocity of 5 meters per second. Gravity slowed it down, okay? It went up 1.3 meters, was displaced up. That took 0.26 seconds. We worked all of that in, so it would have been falling for 59.74 seconds. And if it's falling that long, based on our equation to figure out how far it went for displacement, it fell from the point, not from where it started, from where it went up, stopped, and started going down. It fell 17,505.5 meters. Then what do we do?
Then we plug it back into the displacement equals half times
Displacement equals half
open parentheses, velocity, final velocity plus initial velocity, close parentheses, time.
times time. Like this? Okay, so we got to plug this one in. So we have half, what's the final velocity? We don't know. That's what we're looking for, the final velocity. Do we have the initial velocity? 0, right? Because it went up and it stopped. So this is going to be 0. We can get rid of this. We're going to drop this in. So we're actually just taking half of, and we have the time. We have the time right there. It was 59.74 seconds. So what do? This is back to basic algebra. We need to isolate the variables. So
Divide.
and we have the displacement,
Yes.
right? We have the displacement. So step 5, we have the displacement, 17,505.5 meters. We're going to divide out the 59.74 seconds from both sides. 59.74. What is 17,505.5 divided by 59.74?
Dang, I didn't do this part. I did, but I don't remember.
So we get
293. That's it.
293.
Yeah, and then
Okay.
you times that by 2.
And we, no, hold on. So we're rewriting the formula step by step here. So we have 1/2 times VF, the final velocity. But if you are dividing by 1/2 to isolate the variable, you're actually just multiplying by 2. You can do either one. So what is 293 divided by 1/2 or times 2?
Where did I get from there?
What is 293 times 2? Or you can divide it by 1/2.
586.
Okay, so we do that math, we get velocity final equals 500 and what?
86.
86. Was there a decimal attached to that?
0.1.
0.1. So again, we would round. And anyway, this is in meters per second because we were looking for a velocity. Oh, guys, this is great. If you were able to do either method, wonderful. But again, this is a freshman level intro to physics. This is the hardest problem out of that set for the assignment. So if you threw up your hands after giving it a good try, I'm not going to fault you. It took me forever to figure this out. What?
You?
Yes, me. And I had help. But we figured it out. It took, what did it take? We got the correct answer with the long method first, and it took about 20 minutes. And then we were reworking it to make sure we had the steps, and we realized there's another method. And then we worked that for probably...
I think we also just stared at the board for like a good 10
Oh yeah,
minutes.
you sometimes if stuff's at the peak of your ability because you haven't used it in a long time, guys, I haven't taken a math class.
I have a foggy brain right now because I'm sick. I'm
Oh,
sitting here
excuses.
like, what?
Okay. So anyway, sometimes you do. You stand back and you look at the board and you're like, that's why I don't have any hair left. I just scratch my head and work it out. So anyway, guys, this is a multi-step problem, and those are like the most challenging for a lot of people. So I hope you enjoyed the video. Hopefully you don't have a headache. Proof that we can do it. Your crazy science teacher can do a little math. It just takes me an exorbitant amount of time to do it. Don't let this make you throw your hands up for the whole thing. I'm worried about concepts. Do you understand the why and the how? And a lot of the word definitions, just kind of understanding, hey, what is displacement and what is acceleration? That's what we're dealing with here. So anyway, have a good one.